Hey everyone, welcome to Code Explore. Today we are going to see a problem, longest palindromic subsequence. Okay, so I'm going to solve this problem using dynamic programming and recursion. Okay, so let's see how we can approach the question. Okay, so we have given a string and we have to find a longest substring, longest subsequence, which is a palindrome. Okay, so let's understand what is subsequence. So subsequence is picking any alphabet from string in the same order. Okay, or in the relative order, we can say, like, we if we pick B, we can pick this B, then we pick this B. Okay, but we cannot pick this C after this particular B. Like, there are three B before C. We can write C here, but let's write the B here also. Okay, so now we cannot put C here because C is relatively in back position from B. Okay, so subsequence has that maintained order of alphabets as in the string. Okay, so this is subsequence. So we have to find maximum subsequence which has a maximum length and which has to be palindrome also. Okay, so let's generate the subsequence from the string. Okay, so this is a given string. We have to generate a subsequence. Okay, so for every letter there are two options, whether we include that letter in a subsequence or not include that letter in a subsequence. Okay, so this is an empty string starting. So let's include B. Okay, and here not include, include B, not include B. Okay, okay, then here include this B and not include. Okay, so the string will be what? BB. And what will be here? Only B. Then here include B, again not include B. Okay, so this will be what? B, and the string here will be what? Empty. Okay, now here include A. Here not include A. Okay, so this is basically a recursion tree. BBA, here will be what? BB. So as you can observe, there is a single option. Okay, single possibility. Then we have two possibilities here in the second level. Then we have four possibilities in this level. And for this fourth level, again, every possibility will have further two possibilities. So possibilities will be what? Possibilities will be what? 8. Okay. So the time complexity of this problem is what? 2 to the power n, because possibilities are growing exponentially. Okay. So at the last, in the last level of this recursion tree, we'll have a substrings. Okay, generated substrings. Okay, so for example, this leftmost branch will have this whole substring. Okay, then this rightmost branch will have a empty string as answer also. So this that last branch will have all the possibilities of the substrings. Okay, so among that we have to check whether that string is palindrome or not. Okay, so how we check that? Using the two pointers method. Okay, first pointer pointing to the first index, last pointer pointing to the last index, and then we compare whether the let's say this is a left, this is a right. We'll compare that. Is S of L is equals to S of R? If it is equal, then we do R minus minus and L plus plus. Okay. So likewise, we check whether that is palindrome or not. Okay. So this is a one approach. Okay. So, but what is the problem in this approach? The first one is time complexity of this approach is what? 2 to the power n. Okay. And so let's think how can we reduce this time complexity. Okay. So as you can see, we have taken a B here. Okay. Like we have a count, we have already count possibilities for B. Okay. In this branch. But again, B has come here. Okay. We are counting the possibilities of a B here also. Okay. But we have calculated here. So we can use this answer. We can use this answer here. Okay, so what we can do, we will store this answer somewhere, and whenever the B will come, we can use that answer directly from there. Okay, so this is called a concept of dynamic programming and memoization. Okay, so yes, so using this, the time complexity of the problem will reduce to O of n square. Okay, or yes. Okay, so let's see the solution using dynamic programming. Let's erase this. I hope you understand this recursion tree. Yes. So now what we have done, uh, we have made one function, solve function, where we have a pass or string A and two pointers. That is what? Left pointer and R pointer. Okay. Okay. The initially left is here and R is here. Okay. Yes. Now what we are doing, if left is equals to right. Okay. So we'll return what? 1. That means both left and right are at the same position. Okay, so we'll return what? 1. We found one substring of length 1, which is a palindrome. That means, okay, yes. So if L is equals to R, we'll simply return. Then if left is greater than right, we'll return what? 0. So this is a break condition. Then we have make one two-dimensional array DP for storing the duplicates answers. So this is the concept of memoization and dynamic programming. Okay. So initially we have declared this 2D array with -1. Okay. With -1. Yes. Okay. So we'll check if DP of left right is not equals to -1. Okay. If that is not equals to -1, we'll simply return that stored answer. Okay. But if it is not equals to -1, that means we have to calculate the answer. So we'll mark that -1 to 1 because we are going to calculate that answer. And what we'll do, we'll check if this left and right are equal. If this left and right are equal, then what we'll do we'll increase the length by what? 2. Okay, and also we'll reduce this length by increase this length by 1. Increase this left pointer by 1 and decrease this right pointer by -1. Okay, and we'll add this length. Okay, so as you can see, we have done here. Okay, else if that pointers are not equal, what we'll check whether, see, we have to find the maximum length. So if these two are not equal, so we have to check either in this part or in this part. Okay, so what we'll do, and we don't know what where is the maximum among these parts. Okay, so what we'll do, we'll pass maximum of solve A left and right -1 comma solve A left plus 1 and right. Okay, so we'll pass both and find the maximum among them. Okay, and finally we'll return our DP of left and right. Okay, so this, yes. So this is a solve function. Yes. So let's see code on lead code. So in dynamic programming problems, you just have to declare this array and store the answer in that array. Okay. So next time, whenever that same uh, same question came, we can copy that answer from the previous answer that we have already stored in that array. Okay. So that is the simple logic. Yes. So let's see a code on GFG. Yes. Yes. The longest palindromic subsequence. Yes, you can see here we have declared a dynamic programming array. Okay. Here the length of maximum length of string is what 1000. So we have declared array of 1000 1000. Okay. Then here if left is equals to right, will return 1. If left is greater than right, will return 0. If dp of left right is not equals to -1, okay, that means we have calculated already that part, so we'll simply return that answer. Else if that is not calculated, we'll calculate that part and mark this dp of left right is equals to 1, and we'll check our condition of palindrome, that is if a of left is equals to a of right, we'll increase our length by 2 and we'll increase left pointer by 1 and decrease right pointer by -1. Okay. Decrease right pointer by 1. Else if left is not equals to right, what we'll do, we'll check in between left to right -1 and left plus 1 to right. Okay. And we'll take a maximum of that both possibilities. Okay. Yes. And simply lastly we'll return a answer. Okay. And here memset function we have used to set all values of the array initial to -1. Okay. dp array to -1. Okay. And then we have passed our string and start index and last index to the function, and finally we have written the maximum length of our palindromic subsequence. Okay. So yes, let's run the code. Let's submit the code. Yes. So that's it. So draw the recursion tree by your own and use pen and paper for that. Yes, that's it for this problem. And please like, share, and subscribe to my channel if you find this video meaningful. And yes, stay tuned. Happy coding.